Hello and welcome to the 0PM podcast. This is a podcast where we're going to talk about protecting the environment and human health from pollution caused by persistent and mobile substances. 0PM is going to prevent, prioritise and remove these substances from the environment. 0PM is a research and innovation project funded by the European Union's Horizon 2020 programme.
Hello everyone, this is Hans-Peter Arf, Deputy Coordinator of 0PM, and today we're going to talk about Rachel Carson's book, Silent Spring. It was 60 years ago from now that she alerted the world to the consequences of chemical pollution. Today, many emitted pollutants, like PFAS and many PMT substances that we're interested in, continue to go under the radar. So to avoid more silent springs, we think that future chemical regulation should take a more precautionary approach. So we're going to ask a provocative question to try to get to this. And this provocative question is, what would the world be like today if Rachel Carson had discovered PFAS and not DDT? And joining me for this conversation is the coordinator of 0PM, my colleague, Sarah Hale. Sarah, what are your thoughts about Silent Spring?
Well, I think if Rachel Carson had discovered PFAS and not DDT, the world would be amazing now.
Great. Perfect answer. I think we concluded what the world would be like if Rachel Carson discovered PFAS. I agree, but maybe we should give our listeners some more details about why we think that. So maybe, Sarah, if you want, you can maybe give some background about what Silent Spring, the book, was and what it was all about.
I can do, Hans-Peter. So for those of you who don't know, Silent Spring was a book published in 1962, and it was focused on DDT, which is an insecticide that was used, and it was basically being applied to agricultural land without discrimination. You maybe are familiar with some posters that show planes flying over fields, basically spraying down DDT. I certainly am. I saw those in chemistry classes. But the thing is, in 1962, when the book was released, there was a lot more pollutants that were in the environment, but they weren't really known. And this includes the chemical class PFAS. So that stands for per and polyfluoroalkyl substances. And we find them basically everywhere now. They're in rainwater, drinking water, they're in soils, they're in our blood. So even though they were long in use when Rachel Carson was writing Silent Spring, they weren't actually noticed, probably by anybody apart from those who were manufacturing them. And that kind of begs the question of, why is it taken so long for people to notice PFAS? You know, PFAS and DDT, they do share quite a lot of similarities. They're both very persistent, and you can feel their effects over large spatial and temporal scales. So Hans-Peter, maybe we can reflect, what do you think it would be like, seriously, apart from amazing, but what would it be like if Rachel Carson had discovered PFAS rather than DDT? Maybe environmental policy would look quite different, and perhaps environmental scientists like us would be working on prevention. So preventing the pollutants from getting into the environment in the first place, rather than trying to clean up after something's happened. So should we cast our minds back and think a little bit about DDT? Maybe you can tell us a bit about the analytical techniques and the measurement techniques. How did we detect DDT?
Yeah, thanks, Sarah. And that's an important question to ask because before I go into that, I think there's two things we have to keep in mind. One is that PFAS was being used in many applications around the time Rachel Carson wrote Silent Spring. And the other aspect is that there was no really good measurement techniques to PFAS. And that was part of the problem. Now, but first, I'm going to talk about how those measurement techniques came to be, because I think in many ways it was Rachel Carson's book that gave motivation to encourage research for what we now call environmental analytical chemistry. This was just an emerging field at the time. We don't have all the fancy techniques that we have now. And what Rachel Carson was able to show was that DDT was causing harm to ecosystems and bird populations, and many researchers wanted to follow this up. To do that, they would have to, for instance, get bird samples, take extracts, and look at the amount of DDT in them. And what type of techniques did they have in the 60s? Well, to actually detect DDT, there was only one detector available. And this was developed by a famous scientist called James Lovelock, who was maybe more famous in the general public for coming up with the Gaia hypothesis, which postulated that the Earth functions as a self-regulating system. That's probably what he's most famous for. But in the analytical community, he's maybe more famous for inventing the electron capture detector in 1957. And this is a detector that could detect things like chlorine, and DDT had a lot of chlorine. And when you had this detector coupled with this emerging techniques in gas chromatography, it was possible to take, for instance, a bird feather sample or a bird egg sample, do an extraction, put it through the gas chromatograph to separate the different chemicals, and then quantify DDT. So this is the techniques that were available in Rachel Carson's time. But related to that, this was also the birth of this field, as I said, in environmental chemistry. And so other researchers that were looking for DDT, such as Søren Jensen in Stockholm University, he was starting to see other peaks emerging in his chromatograms. And when you look closer at them around 1966, so 4 years after DDT was Silent Spring was published, he found a new group of chemicals that was ubiquitously distributed like DDT, and these were called the PCBs, or the polychlorinated biphenyls. And these chemicals were used for many different things, such as cooling liquids, because they were not flammable, so you could use them in electrical capacitors and condensers and all kinds of things. But these were also found to be widely spread. And then when they started looking for more chlorinated compounds, they found more and more pesticides that were being globally distributed, such as lindane. And all this together got more concerned about what are the effects of these persistent chlorinated compounds having on the environment. And this eventually led to the Stockholm Convention for Persistent Organic Pollutants in 2001. And they included like the dirty dozen pesticides, which were mainly chlorinated pesticides. And that was the beginning. But PFAS was off the table at that time because we didn't have the measurement techniques. They came later, around the same time the Stockholm Convention was ratified. That was the first time we were getting reports that PFAS was being widely distributed in wildlife. And to get to that point, other techniques developed in the 80s and 90s and then in the 2000s had to go on parallel. And instead of the electron capture detector, we had to use electrospray tandem mass spectroscopy, which was a bit more high tech. And this had to be often coupled with liquid chromatography, not gas chromatography. So this is part of the reason why PFAS went under the radar so long. So we were, I guess, Rachel Carson and everybody else was slower to react. But my question to you, Sarah, is if these techniques to measure PFAS were available in Rachel Carson's time, how do you think this would have affected the past 60 years of chemical management?
It's a good question, isn't it, Hans-Peter? Because it's really easy to cast your mind back and think, okay, if we had the knowledge then, would we have done things differently? Possibly, probably. Perhaps, for example, the way that people decided to manage DDT and PCBs could have been applied to PFAS. That's one thing that might have happened. And it's also not inconceivable to think that PFAS could have been included in the Stockholm Convention already in 2001. I mean, it's taken much longer for it to be included in the Stockholm Convention and other pieces of regulation. But say if it had been included then, would things have been looking different? Most likely. I think what would have happened is perhaps if there was some kind of regulation, then maybe we wouldn't have the same effects that we see now. So now we're really aware of hotspot sites and we're very aware that there's this diffuse pollution. And these hotspot sites are often linked to things like airport sites, paper factories, textile factories, and of course the factories where they actually produce the PFAS themselves. But what's very clear is that PFAS most likely wouldn't have been restricted outright. So that they didn't restrict DDT outright. You know, DDT was still used, is still used, and it's permitted for use when it's essential. So this raises another very important question, which is very, very topical at the moment, is what's essential? How can we decide what's essential? PFAS probably does have some critical roles for society, for our health, in medical devices. So perhaps those could be considered essential. At the moment, there's, as you know, this big discussion happening with the European Commission about the definition of essential use and some criteria to accompany these things. But that aside, if we'd have known about PFAS earlier, I think perhaps there would have been fewer incidences in the environment. We would have had better control, and we probably wouldn't be sitting in the situation that we are now, where we feel like DDT, the history is just repeating itself. And also, if I'm to be negative and skeptical, and I cast my mind 30 years into the future, what will be the next PFAS? I'm pretty sure that there will be one, unless we use policy action, be them, direct or indirect, voluntary or non-voluntary measures, to really stop people from emitting substances, chemicals that are problematic. If we go that way, then perhaps we can avoid something happening again. So my kind of feeling is that we must work with precaution, that's where we need to go next. What do you think about that?
No, I absolutely agree. I think this brings us to a larger point where I think often in chemical management and especially in environmental concerns, but also human health concerns, we are overestimating how much we know. A lot of the field of risk assessment was based on the work of Paracelsus, who said the dose makes the poison. It's not the poison that makes poison, it's the dose that makes the poison. That's true, but what makes that hard to implement is sometimes we don't know what the poison is that we're exposed to. And the other problem is we don't know the dose. And what I think we should be learning from Silent Spring is that synthetic chemicals that are persistent and can possibly have an effect can have many unintended consequences. And so we can't just emit chemicals like DDT and PFAS until we see that there's evidence of damage and then take retrospective action, because often that retrospective action is too late. The damage has already been done. And so all we can do is try to spend a lot of money and remediate a very difficult to remediate situation. So I personally like the approach that the European Commission has been taking with the chemical strategy for sustainability towards a toxic-free environment, because they emphasize a hazard-based approach. If there's some early warning signs that a chemical is persistent, potentially toxic, and it might be mobile or bioaccumulative, but if there's these early warning signs, then it's up to us to prove that the chemical is safe. It's not up to, say, scientists to prove that the chemical causes harm. And I think that's the best way to go. And I hope this is something that we can learn from DDT and PFAS and our experience over the past 60 years.
I agree.
Well, great, Sarah. Thanks so much for having this conversation. I think it was a very important one. And I hope our listeners enjoyed it too. And if you have any comments, feel free to reach out for us or to follow us on our Twitter accounts or LinkedIn accounts and make a comment, and we can have a dialogue about this podcast. And we'd be very much interested in getting your opinion. All right. Well, signing out for 0 PM, this is Hans-Peter Arp.
Sarah Hale. Thanks very much, everyone. 0 PM. Zero pollution of persistent and mobile substances. This project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under grant agreement number 101036756.